Hey, I've got Spencer already. He's one of my students.
Remember, do to pin your video so you can see yourself. Or you can unpin.
Spencer doesn't have his little picture on there.
There you go.
Hey, there he is. Hey, Spencer. Can you
Hi,
hear
how
me?
are you? Yeah, I can hear you.
Good. Excellent.
I don't think that the whiteboard's close enough.
No, I think it needs to be moved higher, doesn't it? Or do you think it's all right like that?
Yeah, we might have to set your computer onto something. So you can ask him how it works. Let's see if setting it up on this would help.
Hey, Spencer,
Yes, sir.
have you had me as an instructor before?
I have not. This is my first class at TCC.
Okay. How old are you?
I'm 19.
Are you a concurrent student? No, you're out of high school.
Yeah, I'm taking summer classes here before I go back to University of Arkansas in the fall.
Fayetteville?
Yes, sir.
Do you like climbing up and down hills?
Oh, it's the best. Like all my classes are at the bottom of the hill, and I live at the top. It's great.
Going from home to, or apartment to class is no problem. It's downhill.
Getting back to the rough part.
Yeah.
Ask him how that works for him.
Well, it's a beautiful campus.
Oh, I love it up there.
Well, that looks pretty good. Can you read that?
So far, so good.
Okay. Well, that might work.
Okay.
Well, we'll see if anybody else is going to show up. I've got also Parker. Come in, Parker. Earth calling Parker. He hasn't turned on his audio or video yet.
No, it's time to mute their mics once you start lecturing, okay?
Yeah, okay.
All right, see you later.
See you later. Have a great day.
You too.
Well, so far, hey, there's Parker. Hello. I'll wave to you. There you go. Parker, you sent me an email.
Yeah, I did.
You were worried about attendance.
Yeah, I was, but
You're
I
not
think
worried anymore.
it should be fine. Yeah.
Yeah, you're fine. I'm going to keep a record. It won't hurt your grade any, but I'd like to know who shows up for the online talks here.
Okay.
But right
Sounds
now
good.
we got Parker and Spencer, and we're just waiting for some more. It's still early.
Yeah.
Now, Parker, how old are you?
I'm 20.
20. Okay.
Yeah.
My other friend here, Spencer, he's 19.
Okay.
Parker, do you go to OSU or where are you going to go?
Yeah, I'm at OSU right now. I'm just taking summer classes.
Good for you. Engineering major?
Yeah, I'm mechanical and aerospace right now.
All right, can't beat that.
Yeah.
Well, do you guys have any questions for me?
I was looking at the textbook stuff, trying to get that figured out, but the bookstore's not open yet, so I couldn't call them. Just sort of trying to figure out what all I need there. I know it's the 10th edition of the book, but
Right?
and I found the EPUB card. Is that just the online digital version of the textbook?
Yeah, you definitely want the ebook.
Right.
Now, are you going to have that ebook on your cell phone or are you going to have it on your computer?
On a laptop.
Yeah, I think it's easier to read. Computers
Sure.
are cell phones are awfully small. Yeah, now I have the phone number for the bookstore. You guys could probably find it, but here, let me put that on here if I can find that. Can you guys read that okay?
That second number, or like, is that 7425 or 7925?
It's a 7425. I make my fours like that.
Gotcha.
Yeah, I can see it.
Now the book, thing is, if you guys got this book, or the ebook, I mean, from Amazon or someplace else, you might be able to get it cheaper, and I think you can rent it. Have you checked into renting it?
Not yet.
Yeah, might be cheaper, you know.
Right.
I'm pretty sure you can use like Amazon to rent it for like really cheap.
Yeah, I think you can rent it.
Yeah, and it's super cheap.
What
I'll
a
look into
deal.
that.
What a deal. But anyway, it's 10th edition. Of course, you guys, this is all on the syllabus, which you've all looked at the syllabus, right?
Mhm.
Hmm.
Yeah. This is all, I'm just repeating stuff that's on there. It's the 10th edition. Fundamentals of thermodynamics. The main author is Borgnacki. And the other co-author is Sontag. And I probably have the here's the ebook ISBN. I don't know what ISBN stands for. Do you know, anybody?
I'm not really sure.
International, I don't know. It's their secret number for the book or the ebook. I guess we could Google it. We could Google it, you know what?
Yeah, I'm looking. It's giving me some weird answers. I don't think that's good. Is it IBSN? ISBN?
It's ISBN.
Okay. Let's see.
N might stand for number.
Oh yeah, it's International Standard Book Number.
That's it. Yay! Now we know what it means. International Standard Book Number. Wow. Well, we learned something today. Today won't be a total waste of our time.
Yeah.
But if you can get that on Amazon and rent it, there's probably other choices too. The bookstore, the Wiley. It's published by Wiley, and I understand that you can buy or rent it direct from Wiley. I think their fancy name is Wiley and Sons, but Wiley will do. Wiley and Sons Publishers. They don't make the printed version exactly like they have been doing, but the publishers told me that they have an abridged printed version, whatever that means. I haven't seen it yet. I've asked them to send me one so I can look at it. But what do you guys have? All you have right now is either nothing or the ebook. Is that correct?
I think so. Yeah.
So, oh, look at, we have some more customers. Look at here. We have Roxana, Cameron, Aubrey, and Mohammed. Welcome, you guys.
Hello.
Hello. Go ahead and put your, hello. Put your picture up there for me so I can see your happy faces. Hey, there's Mohammed. Now, Mohammed, can you
Yes.
hear? Yeah. Have you had me before?
No, this is first time.
Okay, that's fine.
Okay.
What about Cameron? Cameron, I had him before. Cameron, whatever you do, pin yourself where I can. There's Aubrey. Hello, Aubrey. Hey. And there's Megan. What? 1, 2, 3, 4, 5, 6, 7. What about Cameron?
I got a camera ordered. It should be in by next week.
Oh, okay. Good for you. That's Cameron speaking, right?
Yes.
Now, Cameron, you've had me before. You had me this spring, didn't you?
Yes.
Cameron, can the rest of you guys hear Cameron when he's talking?
Yeah, I can.
Yeah.
Cameron, tell them how excellent a teacher I am. Go ahead.
Best in Tulsa.
Cameron's grade just went up. Well, we darn near have everybody here. I'm missing somebody though. See, Mohammed's here. What about Megan? I don't see Megan yet.
I just got in. I'm having a bit of internet issues at the moment, so hopefully it stays okay.
Take your time. That's fine. Take your time. And what about Chris? I don't see Chris. He's not here yet. Parker's here, Aubrey's here, Roxana's here, Cameron's here, Spencer's here. And Megan is hooking up. Okay, well, usually on the first day we talk about the syllabus. And I have I copied the syllabus here. And you should have, every one of you should have the syllabus if you go to Blackboard. And the most important thing is this book here. That's the book. If you can read that, can you read my writing? There's the bookstore number. But you can get the book direct from Wiley or Amazon or I guess Barnes and Noble. Whoever's willing to sell you the book. But everyone should have the online book. I prefer a printed book, and I think one exists, but they haven't sent me the what they call the abridged version yet. But there's a lot of other things on this syllabus. There's how your grade is determined, what we're going to study on given days, when your tests are going to be, the assignments and the homework and when it's due. All that is in this. No, all that is in the schedule. But you should have a schedule on Blackboard. How about it, Aubrey? Have you found the syllabus and the schedule on Blackboard? That was an She has. Good. So you all have the schedule. You all have the syllabus. Anybody that does not? Well, okay, you all got that. Now, I'm not going to sit here and read this syllabus to you and bore you, but I'll answer any question you may have. Does anyone have a question about the schedule? Hey, there's Roxana. Hello, Roxana. She's muted right now.
Hi.
Hello, hi. Does anyone have a question about the schedule or the syllabus? Well, let me look at this syllabus and see if there's anything terribly important other than the book. Roxana just tuned in. Roxana, we told everybody that we think there's a rented version of the book online that's cheaper. Did you know that?
No.
I think you can rent the book. I don't know, for 90 days or something like that.
On
Trying to say,
Amazon?
I'm sorry,
On Amazon?
I still didn't understand.
Oh, where can I rent the book?
Oh, okay, thank you for asking. You can rent it from the bookstore, I think, or Wiley Direct, I think, or Amazon, I think. I haven't actually done it because as an instructor, they gave me the ebook, and so I didn't have to pay any money for it, but I think you can rent it from any of those places, or you can purchase it from any of those places. That's the name of the book, that's the author, that's the publisher, and that's the International, oh gosh, we just learned that. Book number, what's the S? International
Standard, I think.
Say it again.
Standard, I think.
Oh, yeah, International Standard Book Number. That's it. Da, 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 da. Now that's for the ebook. There would be a different number for this, what they call the abridged version. Okay, well, I want to get into the course here and get away from all this boring stuff about books, but you need to have that. All right, last chance for any questions. Well, you can ask me anytime about the syllabus, anytime you want. But we're supposed to study some topics today. And I believe I have you guys for 3 hours from 8:30 to 11:20. Did you know that?
Yeah.
Am I going to be able to survive 3 hours of this? It's risky. But I've done it before. I've done it for years. I probably can. Well, okay, I guess we'll start on our topics. Now, I was looking at the schedule, and it says on the schedule something about definitions and interpolation. That's what it said. Okay. Well, let's talk about definitions and interpolations then, shall we? This is all in chapter 1. I wish everybody was on board. There was one person that didn't show up, but hey, you can watch this video on YouTube. So if you're absent for our online session, the link is right there in the, it's either in the schedule or the syllabus, I forget. But you can listen to the same stuff that we're saying all over again on YouTube, and they have the link there. Okay, well, I'm going to erase this then if you're happy. Last call for questions on that, on the book. All right, well, bye-bye. Now, the topics today are definitions, and interpolation. Let's talk about definitions first. We're going to be studying something called properties. And there's a pressure, temperature, volume, total energy, internal energy, enthalpy, entropy. And this pressure is always a capital P, and temperature is always a capital T, but they have a little v, a little e, a little u, a little h, and a little s. And what those are, all of these things are properties. And these properties are per mass. See, that little v is volume per mass. That little e is total energy per mass. That little u is total internal energy per mass. I bet you guys know that little s would be the big S per mass. I bet you got it by now, right? And that's entropy. We'll learn what that is later. But these little letters are the ones that they have in the property tables. In your book, I'm just looking here, about, I'd say 20% of your book, maybe 50, somewhere around 15 to 20% of your book is tables, they're property tables. And you'll, if you have access to your ebook, the thing is, I don't know if you can do that and watch this at the same time. You'd almost have to have two computers to do it. Howdy ho.
Hey, you might try to scoot your computer a little closer.
Oh, it needs to be closer. Oh, thank you for asking that, mentioning that. Let's see if I can do that. We're going to scoot this a little bit closer. Hang on. Yeah, that didn't work. Can you read that better, maybe? I'm hoping. I bet that's a little better. All right. Yeah. Now, what I was telling you guys was in the back of your book, about 1/5 of your book is property tables. And they have these properties back there. And why don't we talk about each one for a minute? That'd be good. But you'll notice that what they have in the back are these little letters. Now there is no little p, and there is no little t. But the rest are they have the little letters in the back. But let's talk about each one of those. Now the thing about the P is there's three kinds of P's. There's absolute pressure. There's atmospheric pressure. And there is gauge pressure. And then, now sometimes they write gauge the way the British do, G-A-G-E. It's just different spelling for the same thing. I can see Roxana, Parker, Aubrey, and Mohammed. Now I'm going to click that and I can see Spencer. Roxana, there's some of you that are just not on there yet. Now these are related. Here's the relationship. I sometimes use the British spelling. It's the same thing. But that's the relationship between the three. And this absolute pressure, that's what they have in your tables in the back of the book. Those are all absolute. Atmospheric pressure, it varies. Did you know you have high pressure, you have low pressure? The average or the standard is, well, in the English units, it's 14.7 psi. But in the metric, I think it's 101 kilopascals. See, we're going to have to work in English units and System International. They call this System International. I often call this British. Your book calls it English units. It's a little confusing because there's another set of units called the American Customary Standard Units. They're different than these English units. A little bit, not much. See, the American Customary Standard Units uses something called a slug. Some of you may have heard of slugs. But we don't use slugs in this class. We use English units. And the unit for mass is the pound mass. Now, this atmospheric pressure, it can vary up and down. Right now, we have blue skies and dry, beautiful days, and we have a high pressure over us. But maybe in a week or two, there'll be a low pressure comes through. When a tornado comes through, it's very low pressure, and it can suck things up into the sky. Okay, well, let's do a, we're talking about pressure right now. And we're talking about definitions. We'll get to this thing called interpolation here in a while, but we've got to work on this first. Let's talk about this equation here. Let's suppose you had something called a manometer. And this is what they look like. Now they can have any kind of a liquid in here, but they have one kind is a mercury manometer. We're talking about a manometer. It's a manometer. Now in here you have the absolute pressure. And here you have atmospheric pressure. Right in here you have atmospheric pressure. It's open to the atmosphere. But see, if this pressure here, hope you can read my writing, is bigger than the atmospheric pressure, it will push the mercury, and there'll be a difference here, a height difference. It sort of pushes it up. Well, let's do a sample problem. Let's suppose you had The atmospheric pressure was, say it was 100 kilopascals. They have something called a standard atmospheric pressure. It's a 101 point something. We could look it up. But there's a formula for the gauge pressure. It goes like this. That formula has a name if you want to look it up on Google. It's called the hydrostatic equation. And let's say you had mercury. Now the thing is the density of mercury, this stands for density, that rho there, it varies slightly with temperature. But I'm just going to give you a typical value for rho. This is I think that's at about room temperature, around 25 Celsius. Can you read that, I wonder? I hope. I got to find out if you can read that. Let me pick on my friend Parker. Unmute, Parker, and tell me, can you read that number? What does it say?
Is that a 3 or a 7 after the 1?
That's a 3. That's a 1,
Okay.
3. You think that's a 7? Boy, I don't write very good, do I? How about that, Parker?
That's a little better. There we go.
But you can read it now.
Yep.
What's it say?
135.5.
There's no point.
Oh, there's no point?
There's no point. It's 13550.
Alrighty.
Parker, can you read the rest of this stuff?
Kilograms per meters cubed.
Yeah, good going. Excellent. Okay, well, we just figured this out. Now, gravity, there's a standard gravity. Did you know gravity varies all over the Earth's surface? But let's just use a typical value of 9.81. And we'll just make up something for this height. Maybe, I don't know. I'm just making this up. Say this is 45 millimeters. I'll tell you what that would be. Let's see. Here's a meter stick. 45 would be from the bottom here up to my thumb. Yeah. Okay, that's pretty big there. 45 millimeters. Now we're going to calculate the absolute pressure in here. So you put a plus there, and you go 13,550. See, I'm afraid I'm not writing big enough for you guys. And you need to put that in meters. And if it's 45 millimeters, that's 0.045 meters. Now, if you put that in your calculator just like that, you'll get a goofy answer. Because this turns out to be newtons per square meter. See, that's kilonewtons. newtons per square meter. A kilopascal is a kilonewton per square meter. See, a pascal is a newton per square meter. So a kilopascal is a kilonewton per square meter. Now, if you take kilograms per cubic meter times meters per second squared times meters, you will get newtons per square meter. You can't add newtons per square meter to kilonewtons per square meter. What you have to do is you have to multiply this by a little k, and you have to divide it by 1,000. And so then you'll have kilonewtons per square meter, and you're adding kilonewtons per square meter, and you can get your absolute pressure. I've got a bad feeling that I might have lost some of you on that. Let me get the answer for you. Okay, I plugged all that in my calculator, and I got an answer of 105.9 something kilopascals. That manometer is measuring 105. See, it's more. The pressure is more than atmospheric. Atmospheric was 100, and we're getting 105. Now, I want you to get your calculators out and do that, and I want a couple of people to confirm that. And then we'll do another one if we got that down. Well, how about my friend Spencer? Spencer, did you get that when you plugged in those numbers in your calculator?
I did. I got 105.98.
That's what I got. Good going. Okay, well, I'm hoping that you all did. Let's do a different one. Anybody have any questions before we do a different one? Okay, well, I'm going to erase all this. We're going to do a different one now. Now, this is a problem in your book. This is problem 151, actually. And you can find it in your ebook. And it says, it gives you the absolute pressure. And they say it's 135 kilopascals. And they have a manometer. And the atmospheric pressure is 101 kilopascals. And they want to know what this H is. Okay, well, we can do it. We have our equation. Right now we're doing problem 151. It's in your book. It's in your ebook, or if you're lucky enough to have a printed version like I do. We're going to write our equation now. Here goes. 135 kilopascal equals 101 kilopascals plus, oh gee, I forgot that number. Did I get that number right? Is it 13,550? Is that right? If it's not, tell me. I did that from memory. It could be wrong. Now don't forget, I ran out of room here, but you got to multiply by K over 1,000, remember? Should have made that where I had room to write that. Let me scoot it over just a little bit. Here we go. Okay, we're doing problem 151 in your book. And I want each of you to get your calculators. And I want you to solve for H. That's the unknown. I'm going to do it. You do it. I'll shut up here for 2 minutes. And we'll see if we can do this. Go for it. Well, 2 minutes are up. Let's pick on my friend Mohammed. Mohammed, did you get an answer? I got an answer. What'd you get?
Get 133,160 times 10 to the 7th.
No, that's not what I got.
I don't know.
Mohammed, we're trying to solve.
Isn't it?
Trying
Yeah,
to solve.
isn't it H divided by 1,000?
Yes.
Yeah, that's what I got.
I don't like your answer, Mohammed. But don't feel bad. That's all right. You're here to learn, right?
Yeah,
You just want to learn. Let me pick on my friend Roxana. Roxana, what'd you get?
Is it 255.8?
That's what I got. Say it again so I can hear it better.
255.8?
Yeah. Now, what are the units, Roxana?
The meters,
255.8 meters.
I think.
That's not what I got, but here's what I got, Roxana. I got 0.2558 meters. Roxana got the right numbers. But hey, don't feel bad. You're here to learn. Now let me pick on Aubrey here. Aubrey, did you get that?
Yes, I did.
All right. That's how far it is. Now what that is 25 centimeters on a meter stick. It would be from here at the bottom up to 25. Here's 25 right here. Between 20 and 30, it's this distance here from my right hand to my left hand. That's what that H is. Okay, write that down and do it over again if you have to. Let me talk about these units for just a minute. We just did problem 151. I think one of your homework problems is 150. You'll see it there on Blackboard that you're supposed to do. But see, when you're adding numbers, let's say you had 3 feet and you want to add 8 inches to it. Make it 9 inches. This is real simple. You guys can do this. 3 plus 9, that's 12. You don't get 12. You don't add 3 feet and 9 inches and get 12. Even though 3 plus 9 is 12, that's no good. So what you have to do is you go 3 feet plus 9 inches, but see, a foot is equal to 12 inches. You see how the inches will cancel, and you'll get the correct answer. This is no good. What you'll get is, I think 3.75 feet. Did I do that right? Yeah. See, that's what you have to do. Now let's talk about it with the pascals. I hope you all understood that. It's real simple stuff. Let's see if you have kilopascals and you want to add pascals to it, you can't just add them. Well, what do we have before? Suppose you had 3 kilopascals and 9 pascals. You don't get 12, do you? But here's what you can do. You know that a kilo is equal to 1,000. And so if you took a kilo and divided it by 1,000, that's just equal to 1. So you can multiply this by 1. Or you can multiply it by a kilo over 1,000. And here's what you're going to get. You're going to get 3.009 kilopascals. Double check me. Did I do that right? I think I did that right. See, that's what we're doing.
Yeah.
Good. That's what you have to do. If you add stuff, they have to be the same things. We know that. Now let's talk about pascals for just a minute. See what a pascal is. That's how you write pascals. It's a big P and a little a. And what it is, it's a Newton per square meter. That's what a Pascal is. Of course, a kilopascal would be a kilonewton per square meter. Okay, well, that's that. Now, we've talked about pressure a little bit. And we've talked about manometers. Now we're going to talk about barometers. Now you've all heard of barometers. Now what a barometer is, it's a manometer whose absolute pressure is 0. Remember the equation. It goes like this. Now, I didn't tell you this last time, but this can also be a minus. If you got high pressure, it's a plus. But if you have a vacuum, it's a minus. Now, what a barometer is when you have absolute pressure equal to 0. Well, that's a vacuum, isn't it? So you have to use the minus. So here's the equation that you get. This is the equation for a barometer. Now we're going to do an algebra step now. I hope this isn't too difficult for you, but see if you can get to here with me. Were you able to get from here to here? Were you able to make it? Let me pick on somebody here. Let's see. We'll pick on, well, where's the other students? I only have 4 of you guys up here. Cameron, you're with us. You just don't have your picture. Cameron, can you hear me? Earth calling.
Yeah, I can hear you.
Yay, good going, Cameron. Cameron, were you able to make it down here to this last step?
Yes.
Great. Well, we're going to do a problem with a barometer. Now, this is problem 145, I think. Let me look and see. 145. Yep, that's it. All right, we're going to do a problem in the book. It's 145. And it's a barometer, which is a manometer. It's just that it has a total vacuum for absolute pressure. Now, they said a barometer is used to measure absolute pressure. They don't mean that. I don't know if you have a book, but they have screwed up. Hey, did you know books screw up sometimes? Well, they screwed up on this one. The barometer measures atmospheric pressure. So I'm going to cross this out. They got the wrong word there. A barometer to measure atmospheric pressure shows a mercury column of 735 millimeters. Okay, well, here we go. The temperature is such that the density of mercury is, well, we've had that before. And they want what they call the ambient pressure. Now, ambient is their fancy word for atmospheric. Ambient just means air. So we have the equation. For those of you that just woke up from a daydream, we're doing problem 145. In my book, it's on page P3. But I don't know. I'm still confused about the written book or the printed book. Okay, we're going to solve this. Here goes. It's a barometer. So the equation goes like this: 0, atmosphere, or the absolute pressure, is equal to the atmospheric pressure minus rho GH. Make a little room here. Make some room here. This has got to be in meters. And then you have to do that little trick I tried to show you. There's our equation. Now I want you to solve that. And I want you to find the atmospheric pressure. I will shut up again for a minute and a half or 2 minutes. And I want you to do that. Get your calculators. I want you to solve for the atmospheric pressure. There's your equation. Go for it. Well, let me pick on one of my wonderful students here. How about my friend Roxana? I don't see your picture there, Roxana. I guess you haven't got your camera. Yeah, there you are. There you are. My apologies if I've already called on you, Roxana. I'm not trying to pick on anybody in particular, but I got an answer. What did you get?
I got 97.4 kilopascals.
I must have goofed up. I got 97.7 kilopascals. Well, one of us messed up, Roxana, but let me do mine again. No, I got 97.7. Do yours again.
Mm. Oh yeah, 97.7.
Yeah, I bet that's the right answer. I bet we did good on that. Anybody have any other comments or questions on that? Well, okay, let's go on then. Let's talk about temperature a minute. I'm going to erase this unless somebody has a comment or a question. All right. Now we've just studied pressure, and pressure is a property, and you'll find in the tables all kinds of pages with pressure on it. I see all sorts of tables with pressure on it. Now, I haven't talked to you about the English unit, so have I? I got you for 3 hours. We got time. Let's talk about the English units. That'd be good. Okay, next topic is going to be temperature, but we need to know what to do with the English units. Okay, well, let's suppose that the atmospheric pressure was 14.7 psi. And let's suppose the H was I'm just making this up, 20 inches. 20 inches of mercury. Now we're going to find the absolute pressure. And you know the formula, it's the atmospheric. And now that PSI, that stands for pound force per square inch. But now here's where we need the rho in the English. So let me dig around here and see if I can find it. Rho in English. Got to dig around a little bit here. I'm having trouble finding it. Might have to go to the back. Okay, well, let me go to the back and shop around. There's a whole section of British or English things in the very back of the tables. And mercury is 848 pounds mass per cubic foot. And gravity, if you look that up, it varies, but a typical value is 32.2. And we have 20 inches. Okay, now here's our equation. We're using the equation that I gave you guys. Atmospheric plus gauge pressure, which gauge pressure is rho GH. Here, let me write it again. Absolute pressure is atmospheric pressure plus rho GH. That's what I've done. Here's absolute pressure. Here's the atmospheric pressure. Here's rho GH. Now here's the problem. If you just plug these numbers into your calculator, you'll get a real goofy answer. It's no good. Just like before, you couldn't add, what was it, pascals and kilopascals together. You can't add this stuff together. It's got to be the same units. So here's what you have to do. I ran out of room here, but let me rewrite it over here. I need room. I don't have enough room to operate here. I'm going to rewrite this where I'll have enough room to do this. I hope I'm writing big enough to where you guys can read this. If I'm not, somebody speak up. Okay, now I have room to do what I need to do. Let me erase that. Or we could leave it there. It's not hurting anything. Do you notice we have a pound force right here? And that's a pound mass. Those are different, but they are related. And here's the relationship. It is in your book. In my book, it's on page 9. It's probably on your electronic book on page 9 also. But here's the relationship. 1 pound force is equal to a pound force is equal to 32.174 pound mass feet per second squared. In my book, it's on page 9. Hopefully that's where it is on your ebook. So what I'm going to do is I'm going to multiply this by a pound force divided by its equal. That right there is just a unit. It's equal to 1. And when you multiply by 1, you don't hurt anything. Comes out the same. But the beauty is those pound masses are going to cancel out. See that? See how those pound masses will cancel out? Now here's another problem. We're going to have square feet in the denominator. See that foot and that foot cube? That makes a square feet in the denominator, doesn't it? So here's what we're going to do for that. We're going to go a square foot is equal to 144 square inches. That's going to get rid of the square feet in the denominator. So all the feet go bye-bye. Now there's still another problem here. All the feet didn't go bye-bye, did they? Because we still have another foot there, don't we? Okay, I goofed up. What I need here is a foot is 12 inches. Now we have those feet cancel. Gee, I got lost here. All right, now just a minute. We got rid of our pound masses. And we have square feet here. The inches cancel. Okay. I'll get this in just a minute. I think I'm just about there. I think here's what I have to do. I think I have to cube that. I've got cubic feet, and there's a foot, so that makes square feet in the numerator. And I have square feet in the denominator. The feet I finally got rid of the feet. I think the feet, they all cancel. I think the second squares cancel. Now here you have a cubic inches here and inches here. That makes square inches in the denominator. This is ugly. Welcome to English units. They're harder than the metric units. They're ugly. But by using these conversion factors, I think we got rid of the inches. And what you wind up with is pounds force per square inch, because you can get rid of one of those inches and you'll have square inches, and we'll get our answer. Okay, put that in your calculators, and I will shut up again for a minute. I'm going to do it, and we're going to find we are going to find the absolute pressure. If the atmospheric pressure is 14.7 with a mercury column 20 inches high, and I looked up the density of mercury in English. Go for it. I'm going to do it, you do it. Well, I got an answer, and I'm going to pick on one of you guys now. I want to see if anybody got what I got. But I'll give you a little more time. Okay, well, let's see. I'm going to pick on my friend Mohammed. Mohammed, did you do that? Did you get an answer for the absolute pressure?
Yeah, I got 16988.
That's not what I got, Mohammed.
Isn't it 32.2? Oh, sorry, 8480
That's
times 32
848
times 32 point.
32.2
Yeah,
times
times
20
20.
divided by
Divided.
12 divided by 32.174. Now, wait a minute. Let me do it again. You could be right. I could be wrong. I'm going to do mine again. I might have forgotten something.
I got 24.5.
Good going. That's what I got.
Okay.
I got 24.5. Now, Mohammed, I need the units on that. What are the units?
I didn't find the units yet, but
Well, I want you to think about it.
just give me a sec.
Whatever these units are, they have to be the same, remember? Same units here equals the same units here plus the same units here. Got to be the same. What are those units?
Pound for per inch square.
I think you said it right, but say it one more time, Mohammed.
Yeah, it's pound per inch square.
Yes. Yes. I don't have room to write it, but I'll write it down here. It's pound force per inches squared. Now the way you write that is PSI. That's what PSI stands for. It's pounds force per square inch. And I got 24.5. And I think Mohammed and I did it right. We got 24.5 PSI. Anybody else have a comment or question on any of that? Okay, well, let's talk about temperature for a minute, if we think we're through with all that. Did you notice working with the English or the British units is difficult and confusing? But that's tough. That's just the way life is. The thing is, in the United States, we still use miles, gallons, inches, feet. When you go to Mexico, they use kilometers, liters, centimeters. They use the metric stuff. Well, that's every other country in the world. I think there's maybe one or two others that use the English. The English don't use the English. I don't know this. I haven't been to England in a long, long time. But I think they use kilometers, but I could be wrong. Anybody been to England lately? Okay, now we're still doing definitions and we're going to talk about temperature now. Now there's 4 kinds of temperatures in here. There's wonder if I could scoot this over this way, just not much. Yeah, that helps a little bit. There's Kelvin, Celsius, Fahrenheit, and Rankine. There's 4 kinds of temperature. Now, temperature is a property, and in the back you have property tables. And you find temperature all over the place. Temperature, temperature, temperature. Well, here's how it works. Kelvin is equal to Celsius plus 273.15. Celsius is equal to 5/9 Fahrenheit minus 32. Fahrenheit's equal to Celsius. Trying to remember this from memory. That's kind of hard. Celsius equal to Celsius times 9/5 plus 32, I think. And Rankine is equal to Fahrenheit plus 4. Let me double check this. I don't want to lie to you guys. Let me make sure I did that right. Says here temperature. This is in the back of your book at the beginning of the tables. I bet that's right. I bet that's right. What about Fahrenheit? Yeah, I think those are all right. Oh, this is wrong. It's 459.67. Okay, I think all those are correct. Well, let's do some examples of that, shall we? We use 4 different kinds of temperatures in this class. The tables have Celsius and Fahrenheit in them. If you go back and look, there's Celsius and Fahrenheit. But let's suppose you had what's today going to be? Didn't they say it's going to be 85 temperature today? Seemed like that's what the radio said. Let's suppose you had 85 Fahrenheit. We got to convert that to Celsius, Kelvin, and Rankine. See, this is called Celsius. It's Kelvin, Rankine. See, Kelvin and Rankine are what they call absolute temperatures. If you have 0 absolute, your molecular motion is supposedly stopped. Nothing wiggles. Okay, let's do Celsius. Well, let's see, to get Celsius, you'd go, well, you'd have to subtract 32 and multiply by 5/9. Let me do that. Let's see, you take 85, subtract 32, and multiply by 5/9. When I did this, I got 29.4 degrees Celsius. Now to get Kelvin, you just add 273.15. I get 302 point rounded off to 6 Kelvin. Now to get Rankine, you just add 40, 459.67. I'm getting 544 rounded off Rankine. I'll wait a tiny minute while you guys verify that, make sure I did that right, and then we'll do it. We'll do a different one.
I have a question about your answer for Celsius.
Yeah,
Wouldn't you multiply that by 5/9 before you subtract the 32? Because I got 15.2 instead of 29.4.
okay. I think I did it right, but here's how, who was that?
That was Spencer.
That was Spencer. Here's how we can check it. Let's plug in 32. You know 32 Fahrenheit is freezing, right?
Right.
So if you go 32 minus 32, you get 0. 0 times 5/9 gives you 0. So 32 Fahrenheit is 0 Celsius. That checked out, didn't it?
Right.
Now, are you saying you take 5/9 of 32? Or 5/9 times 32? Is that what you're saying to do?
That's what I did, and I can see why that's not correct.
Not going to work. I think this is correct, Spencer. But I appreciate the offer there. And if you keep trying, and you'll be right sometime, because I make mistakes. Spencer, we're going to do another one to double check here. Now, you know that 212 is boiling, don't you? 212 is boiling. Okay, let's take 212, subtract 32, and multiply by 5/9. You get 100. If you have 212 Fahrenheit, it gives you 100. And that's correct. 100 Celsius is boiling, right?
Right.
So this equation's good. All right, well, let's do give you guys another one. You've had enough time to play with that. Let's suppose we had a different one. Let's suppose you had, I'll just make something up. I think in the winter, it could get down to 15 degrees Celsius. I bet it could get down to 0 Celsius, don't you? That's freezing, right? It gets down to freezing here in Oklahoma in maybe January or February. Now, what I want you to do, I'm going to shut up for a minute and a half or 2 minutes. I want you to find the Fahrenheit and the Kelvin and the Rankine. I will be quiet. Go for it. Well, I gave you a little time there. I bet some of you figured this out. I'm getting the Fahrenheit is 59 degrees Fahrenheit. And then the Rankine I'm getting is 518.7 Rankine. And the Kelvin I'm getting 288.15 Kelvin. Anybody have any trouble with that? Okay, well, we'll move on then, if you're happy. Let me ask somebody if they're happy. Let's see, we've got Parker there. Hey, Parker. There you are. Hey, Parker.
Hey,
Are you happy?
I am.
He's got it. He's all right. All right, well, let's move on. If you guys are happy, I'm going to erase all this and talk about properties some more. These are all properties. Temperature is a property, pressure is a property, volumes. I'm going to erase this. Okay, nobody said anything. All right. Now I've been talking about properties this and properties that and properties this. But what the heck is a property? And I'm going to tell you what I think a property is. A property is a description Is description with an E or an I? Does anybody know how to spell description? I think it's an E, isn't it? Come on now. I need help.
Yes, it's with an E.
This is wrong. Now, who was that just spoke up? Was that Spencer? Spencer, I'm going to give you a thank you point up here in the corner. We'll have a little pile of thank you points for students that help out the old professor that doesn't know how to spell words like description. But I think you're right. It looks better now. A property is a description of a mass. You need to have some mass at an instant of time It's a description of a mass at an instant of time. And this is difficult to explain, but it doesn't depend on how it arrived. Well, let me say this first, though. It's a description of a mass at an instant of time, semicolon. It has a numerical value. It has a numerical value, like, I forgot what our answers were, but something like 25 psi or 150 kilopascals. It had numbers. Properties have numbers. It has a numerical value and it has units. Now you'll discover I oftentimes put my units in brackets. The brackets are a dead giveaway that we're talking about units. And they're to keep me from getting confused. I'll try to explain later why that is. But there's one other aspect to a property. It has numerical value and units, semicolon. And it is independent. Different ways to express this. How about it doesn't depend on how it arrived there, or it doesn't depend on the history or the past. How about that? It's independent of its how it got there. Like for instance, the temperature right now in this room where I'm at, it's nice and comfortable because my wife has the air conditioning on. It's probably about 70 degrees Fahrenheit. Look, it's got a number. And it has units. Here, I'll put the units in brackets for you. There we go. See, those are units. And the temperature in this room where I'm at right now describes the air. We're talking about the mass of the air in this room. Well, air has mass, you know. It's not weightless. It's what has got oxygen and nitrogen mainly. They weigh something. And it doesn't depend on what it was yesterday or earlier this morning or what it's going to be tonight. It's right now. It's a description at an instant of time. We're talking about right now. Right this instant in this room, the pressure is 70. Now, there are some things that do depend on how they arrive. For instance, work and heat transfer. They use Q for heat transfer. They can't use H because H is used for something called enthalpy, which we'll learn about. So they use Q for heat transfer. And see, little w, little w is big W divided by M. And little q is big Q divided by M. And little h is big H divided by M. Now this is a bad thing for me to put those in the same pile because H is a property and you'll find it in the property tables. If you flip through the property tables, yeah, there's H's all over the place. I see H's, there's H's, yeah. H is a property, but you know what? You won't find any little W's and you won't find any little Q's in the property tables because they are not properties. They do not exist at an instant of time. To do work is something that's done over a period of time. It takes time to do work. Don't you get paid by the hour if you have a job, or by a week, or by a month, or a year, or whatever? It's sort of the difference between your the difference between properties and things like work and heat transfer, it's like the difference between your bank balance and your weekly pay. Your bank balance exists at an instant of time. You can call the bank and you can say, how much money do I have in my account? And they'll say, well, today at 3 p.m., you have so-and-so dollars. That's like a property. But see, things like work and heat transfer, they take time. It takes time to transfer heat. It doesn't exist at an instant in time. It takes time. It takes time to do work. And you will not find little W's and little Q's back here in the property tables because they're not properties. So now I've told you what properties are. Do you have any questions? Okay, well, look, I get you through for 3 hours now. It's 10:05. And we're going to take a 10-minute break. I'm just going to leave this thing hooked up. I'm going to go maybe see if there's anything in the refrigerator. And I'm going to come back. I'm just going to leave everything the way it is. And we're going to study interpolation. But before I go, you're free to ask me anything. Go ahead, ask. Now you've got some homework. If you'll read your, I think it's in the announcements on Blackboard. It's on your schedule on Blackboard. There's 2 homework problems. They're due Wednesday. I want you to submit them on Blackboard. Now, my friend Cameron doesn't have his picture up there, but Cameron, let me pick on you for just a minute. Are you still with me, Cameron?
Yes.
Can you tell the others you were able to successfully pass my course? Or have I forgotten? Yeah, you passed, didn't you?
Yeah.
You were successful in submitting homework on and exams too on Blackboard, weren't you, Cameron? Earth calling Cameron. Come in, Cameron.
Yes. Yes, I was. Sorry.
Tell the others how you submitted your things, the homework on Blackboard. Tell them how you did it.
I don't know if I can explain it well enough.
Well, that's okay. Just try. Did you use a scanner or did you use your phone? How did you do it?
I just took a picture through my phone and did it
Yeah.
through my phone.
And did you make a file?
Yeah, basically.
You made a file and you put that file for me on Blackboard, and I clicked on the file and pulled up what you did, right?
Yeah, you had specific files for specific assignments of what you wanted.
Yes.
They were labeled.
Well, maybe they can figure it out. Let's hope. Okay, we're going to take a 10-minute break. I will be back in 10 minutes. Go to the bathroom, go stretch, go do something. We'll be back, okay? We need a break, don't we? Oh, I'm stiff. Okay. See you in 10 minutes. Well, I wonder if anybody's back. I gave you 10 minutes, maybe more, I don't know. Hey, there's a couple of customers right there. Yeah, good. Good going. Some of us are back now. That's good. Okay, well, I've got you. Well, I think we have another hour. It's from 8:30 to 11:20, I believe. 8:30, 9:30, 10 to 11. Yeah. So I've got you for another hour, and we're going to study interpolation. And what that is reading between the lines in the tables. So we're going to, I copied down this stuff for ammonia. It's in the tables. Let me tell you where it is in the tables. It's ammonia, and it's table B.2.2. This is table B.2.2. We use ammonia and water tables a lot. You might want to figure out a way to, if I were you, of making paper copies of the ammonia and water tables. Just a suggestion, but you don't have to. Once you learn your way how to look things up on your computer or your phone, you don't need paper. I'm just an old-fashioned guy, and I like paper better. But let's go through a few interpolation problems. Like, for instance, suppose you were told that you had ammonia vapor, and it was, suppose you had a problem where you had ammonia. That's the formula for ammonia. I forget the structural formula. I'm a little rusty on my chemistry. You suppose it's like that? Where's my organic chemists when I need them?
Looks right.
Don't quote me on that. I'm kind of rusty. But anyway, if you were given 300 kilopascals, you know what that is? That's roughly 3 atmospheres. It's 3 times sea level pressure. If you take a breath of air, here we go, ready? That's 100 kilopascals. But you don't want to take a breath of ammonia. Man, isn't that what they used to wake people up? They used to call it smelling salts. Ever hear that, smelling salts? You take a whiff. Well, you know what ammonia smells like. It'll practically knock you down. It'll wake you up. But if you had ammonia and it was at 300 kilopascals and 40 degrees Celsius, these are what they call the specific volumes. You could just read it off the table. 300 kilopascals, 40 degrees Celsius. Specific volume is 0.49636 cubic meters per kilogram. Yay, that was easy. But see, we're going to run into situations where it's not in the table. For instance, suppose you had ammonia at 300 kilopascals and 45 degrees Celsius. Well, see, 45 degrees is halfway between 0.49 something and 0.51 something. Well, we can do that. It's not rocket science. We just got to find a number that's halfway between those. Now, how do you do that? Well, one way would be to add these two and divide by 2. I'm going to try that. 0.49636 plus 0.51382 divide by 2. Did you get 0.50509?
Yeah.
Yay! Well, that was easy. So we could do that. See, the answer here would be 0.50509. Now let's see if you can do it for 400 kilopascals. Suppose you had ammonia at 400 kilopascals and 45 degrees Celsius. Well, that's going to be halfway between these. I'll give you a minute to do that. I'm going to do it. See if you can do it. Okay. Now I'm going to pick on somebody. I don't know if I picked on Spencer recently. Spencer,
I got 0.37555.
That's what I got. I got 0.37555. Now, the units are important, so I'm going to write those down. This thing here has a name. It's called specific volume. That's its name. And it's a property. And we know what properties are. They're descriptions of a mass at an instant of time. They have a numerical value. They have units. Here, I'll put them in brackets. And they are independent of how they arrived at that value. Doesn't matter what they were yesterday. Okay, great. Well, let's do a little harder one. If y'all, little Southern talk, if y'all are happy, I'm going to do a harder one now. Nobody said anything. So we're going to do it. Yeah, let's do a harder one. Okay, what if you were working a problem and you need to go 43 degrees Celsius? We're going to have 43 degrees Celsius and we'll do it at 300 kilopascals. Now here's the problem. This is what we have in the tables now, but they don't have a 43 degrees Celsius. We're going to have to interpolate. This word interpolate is just a fancy word for going in between the lines. They don't give you everything. They don't give you 43, but we can do it. So at 43, we're going to find this number here. It's not halfway between, is it? I'm going to shut up and let you try it. And then I'm going to do it, and then we'll show you how I did it. Okay, go for it. I'll be quiet. Let's see if you can get it. Well, has anybody got that yet? Mohammed, have you got that yet?
No, I didn't get it.
That's fine. That's fine. I want to see if anybody's got that yet. How about my friend Aubrey? She's still working on it?
I got 0.50159.
That's what I got, Aubrey. I think that's right. I think it's 0.501598. That's what you got, huh?
Yes.
Yeah. Well, let's show the rest of them how to do that, okay? Because we got to know how to do this. Here's what you do. You're going from 40 to 43. And that's from 40 to 50. And then what you're going to do is you're going to multiply by 51382 49636. Now, when you get all through, you have to add. Let's draw a line here so I don't confuse myself too badly. You have to add the 0.49636. And what you get is a 501,598. That's how to do it. You have to find out, going from here to here, what this amounts to is 0.3. If you'll do this whole thing here, you get 0.3, 30%. And then if you take 30% of this difference, see, that's the difference between here and here. That's what you're doing. You're taking 30% of this difference, and then you're adding it to what you start with, the 49,636, and you get your answer. Did that make a lick of sense to anybody? How about you, Parker? Did that make any sense?
Yeah, it makes sense.
Okay. Well, I'll shut up and I want you to do this one then. And now this will be the same 30% at 43 degrees. It's 3/10. I'll shut up. You guys do this one and tell me what you get. I'm going to do it. I want you to do it. Now, Aubrey did a really fine job on that last one. Have you got this new one yet, Aubrey?
I got 0.372866.
That's what I got. Now here, I'll write it for you. Now, this is the same. It's just that we're going between here and here now. Now that's how you do it. And I think that's the right answer. Now we'll do another one here and see if you guys caught on. Everybody okay, ready to do another one? We've got to know how to do this. Now let me warn you, doing this is really fifth grade mathematics. It's not that complicated, but for some reason, some of my students have trouble with this. I don't know, some kind of a mental block or something. If you do, don't feel bad. Some of my brightest, most intelligent students have trouble with this. It's nothing to worry yourself about. You'll get it, but we have to get it, because if we don't, we can't work problems at 43 degrees Celsius. Okay. Any comments or questions before we'll do a different one? All right. Well, here, let's do a different one. Here we go. If you're happy, I'm going to erase these. Now, if I'm going too fast, you guys yell at me, okay? Somebody speak up. Mr. Griffin, you're going too fast. Slow down. All right, let's try something else here. Let's try, we go 46.2 degrees Celsius. And we want to find the specific volume here and here. All right, it's going to be different. I think those numbers would be the same though, wouldn't they? Yeah. What's different is this here. All right, go ahead and try that. I know this is boring and tedious, but a lot of things are boring and tedious. Washing dishes is boring and tedious. But if you love your family and the dishes are dirty, you wash them. You just do it. Okay, we can do it. Here goes. Well, I got this number here. Now, this is what I'm getting, but I need to have at least 2 students verify, because I can goof up too. I'll wait a minute, but I want to know if anybody got that.
That's what I got.
Yay!
That's what I got.
I bet we did that right. Okay, now I'm going to do this one. This is what I'm getting for this one.
I got that.
Good. I bet we did it right. Now, if you're not getting this, you should write this down. And tonight, push your buttons on your calculator till you do get it. Okay, great. Well, let's do something slightly different, shall we? Let me erase this. Now, what we just did was we took some numbers from the table and we interpolated. What we're going to do now is we're going to back interpolate. This time I'm going to take a number here. Let's say you were solving one of our thermal problems and you got this and you wanted to know what the temperature was. We have to back interpolate. We're going to get a temperature between 40 and 50. Can you see that? I'm going to shut up and see if you can do it. See if you can find the temperature if the specific volume was 0.50251. All right, go ahead and try it. Then we'll do it together. Well, I got that. And I think I know what this temperature is to get this specific volume. Let me pick on maybe my friend Roxana. I'm picking on you because your picture is up here. And I'm not picking on these people that didn't put their picture. I need to pick on somebody else. But right now, Roxana, were you able to get the temperature? What do you think?
Yeah, I got 43.52.
That's what I got. Proud of you. Good going. Good going. Now, let me write it out for anybody that might be having trouble. Okay. I'm going to write this out. First you get that. Now I did that. And I lost it, doggone it. But then what you do is you multiply by and you add 40. And what I got was 5, 43, 52. I'm gonna double check that, make sure I'm not lying to you. Nope, I believe that's right. If you want to carry out more numbers, it's 5, 1, 7, but we probably don't need all those numbers. Good going. We just did a back interpolation. Any questions on that? See, what this amounts to is 35.17%. You're taking 30 from here to here. Well, you can see it. You can see it's 35.17% from here to here. And the reason is it's 35.17% of the way from here to here compared to the whole distance, if that makes sense. There you have it. Okay, if unless somebody has a question, we'll do something slightly different. All right, if you're happy with that. Okay, let's suppose this time that we're not going to back interpolate. We're going to interpolate the pressures. Now, what we have here is in the tables. I just copied these from the tables, table B.2.2, and I'm hoping every one of you has access to those tables, because you're going to have them to do your homework and your exams for sure. But let's suppose you had a pressure of 382 kilopascals. And at 40, let's say we're going to do it at 40 degrees Celsius. What I want to know is what number goes right in here. Now, when you see me make kind of a cloud like that, I call that my mystery cloud. That tells me I'm trying to find that. That's an unknown. Here, let me make it a little bit bigger. This is my goal. I'm trying to find what number goes in here. It'll be a number between these two numbers. Now watch out, because these numbers are getting smaller. See, 49 is bigger than 36. We have to find what that number is. We've got to be able to interpolate for the specific volume. See, these are cubic meters per kilogram. What we're doing right now is, here's the problem. We're given ammonia. It's at 382 kilopascals and 40 degrees Celsius. And we're trying to find the little v, which has a fancy name. It's called the specific volume. This is what we're doing right now. Okay. Well, again, I think I will shut up and see if you can figure it out. Now, watch out. These numbers are getting smaller. Go ahead. Well, I got an answer there for the specific volume at 382 kilopascals and 40 Celsius. How about Spencer? I haven't called on you lately, Spencer. Or have you got that yet?
I got 0.3917936.
Gee whiz, that's what I got. I think I've got an exceptionally intelligent group here. You guys keep spitting out correct answers. That's what I got. 3917936. That's probably enough numbers right there. That's cool. Okay. Well, then let's, oh, maybe I should write it. That'd be a good idea, wouldn't it? I got a feeling there's got to be somebody having trouble with this. But here's what you do. You take 382 minus 300, divide by 400 minus 300. And what that gives you is, let me write that down just a minute. Well, you can almost do that in your head, actually. Wouldn't it be 82%? Isn't this whole thing just 82%? Yeah. And then what you do is you multiply by 49636 minus 0.36884. But see, you have to subtract that from there. You have to put a minus sign in front of the whole thing. That's one way to do it. Or you could do it this way, take that minus that. Doesn't matter. But if you do it this way, you should get the right answer. You should get 0.39179. Let me make sure I did that right. I must have done something wrong. Let me try that again. Maybe I goofed up here. Nope, I believe that's right. That's how you do it. Okay, great. We did great. Well, let's do this one here. I'll make my mystery cloud here. And we'll interpolate between the 300 and 400 kilopascals. We'll go 382. Now, what we're doing now is at 50, though. It's at 50 Celsius. We're trying to find the specific volume at 382 kilopascals and 50 Celsius. I'll shut up. We'll go for it. See if you can do it. Well, I got this answer, but I'm hoping that several of you got the same answer and I did it right. How about it? Anybody getting that?
Yes, that's what I got.
There's two of us. I need another person to really feel good. I want
I
that.
also got that.
Hey, I'm getting that warm, fuzzy feeling inside. I bet we did that right. Now, the last thing I'm going to show you on this interpolation. Now, there's a homework. If you'll go to your, I guess it's on the schedule there. There's an interpolation homework. You have to download it, do it, work it out on paper, and see if you can figure out how to send it to me on Blackboard so I can get it by Wednesday. I'll grade it and you'll know probably Thursday how you did on your homework. The homework is worth 4 points. In the syllabus, it says how I like the homework done. I like you to write out the whole problem on engineering paper. See if you can get some engineering paper, but I won't be picky about it for a while. Because, you know, it's kind of hard to go to a store now, isn't it? But they're starting to open up places. You could use graph paper. Do the best you can on that. But what we're going to do now is called double interpolation. So I'm going to erase all this because I think most of us, but see, if you wrote that down, you could go home and if you didn't get it, you could figure it out. Okay, I'm going to erase that in here. We're going to do a back interpolation problem. And then I'm going to talk to you about the tables in general. I've still got 15 minutes of your time. 11:20 is when this is over. And it's on, if you didn't get any of this, you could watch it over again on YouTube. There's a link there. If you click on it, you can watch this whole wonderful program over again. Okay, now what we're going to do now is, here, let me erase this stuff here. Now this stuff that we just did is not in the tables. We have created it. We have found these values here by a lot of hard work. And now what we're going to do is what they call double interpolate. Now I'll try to avoid giving you these because it's nasty. but it can't be helped. It happens in real life. We'll give you one that's fairly easy. Let's say you wanted to find 382 kilopascals at 45 degrees Celsius. Here's the problem. You're given ammonia at 382 kilopascals and 45 degrees Celsius. Well, can you see that's going to be halfway between the 40 and 50? It's going to be halfway between these two. Now, I could have made it harder by making it something harder, but go ahead and tell me what the answer would be if you were given 382 kilopascals and 45 Celsius. Go for it. Well, I did that, and I got halfway between these numbers as 0.3988. I guess you could round it off to 7. And the units happen to be cubic meters per kilogram. There's the answer. And I'm going to wait for an from a couple of students to feel good about that. Did I get that right? I didn't hear any.
Yes.
Oh, there's one. I need another one to feel really good. I want that warm, fuzzy feeling inside.
That's what I got too.
Yay, I bet that's right. Okay, well, that's interpolation. I've shown you everything I know about it. And it's ugly and tedious and boring, but so is washing dishes, okay? Just something that's got to be done. Now I'm going to erase all this, and we're just going to talk about tables in general. Unless there's a comment or question. Okay, well, say goodbye to that. We've studied that, and you have some homework to do. And then say, we'll meet again on Wednesday. And you can look at the schedule and see what we're going to study. And you can read your book. It tells you the chapter to read. But I'm just going to tell you about tables in general. Now, there's a method to how they have these tables. They have the water tables first, then they have ammonia, and then after ammonia, I forget, but I'm gonna look it up. Okay, there's the water. There's ammonia. And after ammonia, they have CO2. And then they have a refrigerant, the kind that I have in my house. And then after that refrigerant, they have another kind. This is the kind of refrigerant I have in my car. And I bet you have that in your car. And then after that, they have nitrogen, methane, and that's it. And all of that is in SI, or what we used to call metric. metric. Then guess what they do? Then they start all over again, and they do English. And they have water in English. They have ammonia in English. And then they have CO2, I think. I don't want to lie to you. Now, let me look and see. There's water in English. And then there's ammonia in English. Yeah, I haven't lied to you yet. And then they have, I don't see the CO2. I think they skipped the CO2. They didn't do it, but they do have the R410A. They have the R410A. And then they have the refrigerant R134A in the tables. And then they have that's it. They ran out. They don't have nitrogen or methane, so they don't have quite as many. But you all understand now, these are all in units like PSI and degrees Fahrenheit and things like BTUs per pound mass. Whereas these, all of these tables are in kilopascal degrees Celsius and kilojoules per kilogram. See, those are metric, these are English. That's what you got in the back on your tables. Now let's just talk about the water tables for just a minute. Any comment about the tables? I've still got 5 minutes here with you guys, and these are precious minutes. We don't really have enough time to teach this course, but that's nothing new. It's the same at OSU. They don't have enough time either. We're just going to talk about the water tables. We got 5 minutes, so here goes. Unless you have a question. Well, there's all those tables in the back, and now we're just going to look at the H2O tables, and we'll just look at the SI tables for H2O. And I'm digging around here. And this is table B.1 is the name of it. And it's the saturated table. They have what they call a saturated table. Well, what that means is it has water. Actually, what it is, it's a saturated mixture of liquid plus vapor. This first table they have is a mixture of liquid plus vapor. It's a saturated table. And then after the saturated table, they have the superheated table. Now this one was B.1, but the superheated table is B.1.2. And see, there's no liquid there. That's all vapor. Do you understand? It's all vapor. There's no liquid, no water droplets. And then after that, after the superheated table, they have the compressed liquid table. Now that's table B.1.4. They call it compressed liquid. Now it's all liquid. There is no vapor. It's all liquid. Now some books call it supercooled water. They call it supercooled. Instead of compressed liquid, there are thermo books that call it supercooled. And then finally, after you flip a few more pages, they have the saturated solid. Table B.1.5. They call it the saturated solid table. Basically, what you're dealing with here is ice, okay? They've got a table for water when it's frozen, when it's ice. So you can have solid water, you can have liquid water, you can have vapor, and you can have a combo. Actually, to keep from lying to you, the saturated solid also has some vapor, but it's ice vapor. I don't know if you've ever seen cirrus clouds high in the sky. They look different. They're not fluffy. They're made of ice. And in Alaska, you can have cirrus clouds right on the ground, and it's called ice fog. Well, we're going to talk about all of this more next time, but we've had a wonderful time. And those of you that want to watch this on YouTube can. Got some homework to do. So I'm going to push the button that says goodbye here, unless you have a last comment or question. We're going to say adios for now.
I got a question about the book.
Yeah.
Where can we find that?
I talked about that at the very beginning. You might not have tuned in then, Parker. Go back and look at the YouTube and read the syllabus. You can get your electronic book, ebook, from the bookstore, and I put the phone number on there.
Okay.
On the YouTube, and I have it here someplace. I might be able to find it for the bookstore. I have to dig around just a minute. We'll find it here. The bookstore number, am I talking to Parker? Parker, it's 918-595-7425.
Okay.
But now it's Friday. It's whatever they call that virus thing going on. They're probably not going to answer anything. But I also said you could get the book direct from Wiley.
Yeah.
Amazon. And I also mentioned that it's possible to rent the book. Save yourself some money.
Yeah, I'll probably just end up renting it.
Oh, yeah, that would be the thing to do if you can do that. Now, I don't know if Barnes and Noble has it or Amazon has it or Wiley has it or the bookstore, but keep trying and see if you can't do that. Now, part of the homework is interpolation, and you don't even need the book for the homework on interpolation, but you will need it on problem 150. You might want to make a friend in the class. I don't know if you know any of these other people, but that'd be nice for you to have a friend.
Yeah.
Well, I'm not supposed to give out people's numbers and things, so I don't know how you're going to get their number. But
I'll find the book.
yeah, it's just kind of weird, you know, this doing everything from home. This is my first time to, well, I did some online last semester, but just for part of the semester, because see, we started off with face-to-face till spring break. So I got to know my students.
Yeah, that's what we did too.
Okay, well, I'm gonna, any other questions before I say goodbye?
I'm good.
Okay, well, see what you can do, and I will see you Wednesday at 8:30. Bye-bye,
good.
everybody.
See ya.
Later.
Ta-ta.